And so now we've got a twofer. We've got Bjarne Stroustrup as well as Gabriel Reis. Gabriel, tell us first about your talk.
Okay, my talk is about the State of the Union of C++ module proposal for post C++ 17, and something that I think almost all C++ programmers are waiting for to get their hands on. Bjarne, what did you want to say this week?
I was talking about the evolution of C++, sort of seeing it come from the dark ages and going through 14 and soon 17 and beyond, and explaining what was the fundamental aims, the fundamental techniques, and the basis of everything, and then also showing how we could get where we're going beyond this. And a good example is modules, as Gabby is doing. It's not in the standard, but it's in a technical specification, and it's shipping, as it were, in Microsoft. Another important feature in the future is concepts, which is shipping in GCC.
Right.
I and Gabby and Andrew Sutton are the main workers on that one. And then there are things that are coming in 17 that also is sort of part of the future path of C++, like structured bindings, which again is our handiwork together with Herb Sutter.
Yeah.
And so I was trying to do the big picture. There's so many talks here that are about some specific things, or how to do a specific things, or a library, and I was trying to be broad, but not so deep into technicalities.
So if you're working C++ programmer and you spend more time writing codes and compiling and debugging than reading the fine arts of the standard specification, how would you describe a technical specification for the working program?
Oh, a technical specification, I would say it's sort of a junior standard.
Someday it will grow up.
It'll grow up to be a real standard real soon now.
Okay.
Sometimes it only takes about a year, and it's an intermediate stage. Sometimes we need some feedback from the community to polish the corners. Sometimes it makes the development of the language faster. Sometimes, unfortunately, it slows it down because it's an extra bureaucratic stage. But
it has worked for the file systems,
it works,
the network.
It works very well for libraries, though I would like to have had Azure, the networking library, in C++ 17, but by and large it works, and when there's a technical specification you can actually use this stuff. I mean, Azure is a good example, file system was a good example, that was a technical specification.
Yes.
Now it's becoming real, but you can use it in production code. It's a technical specification tends to be better specified and better thought out than a lot of commercial software. So it
does good stuff.
And I mean, at least with the respect to like the ones that we ship in Microsoft, I've been very actually impressed with the level of community engagement we get. We get excellent bugs from people, and really people really do try it out. It's great.
Yeah.
So the C++ 17 has a lot of features, library features, and can you tell us briefly how it changes the structure of code that people write?
I don't think it changes the structure in fundamental ways in general, but it helps individuals. There's something there for everybody. It's not massive, shocking, revolutionary, but I can't imagine a working understanding of modern C++ programmer for whom there isn't something.
Yeah,
I mean,
so for
maybe
example,
you want variant.
Variant, for example, is something that we adopted very recently on code base and prevent us from writing bugs.
It saves us from bugs. It saves us from writing too much code. It saves us from having unsafe unions in that many places. Structured bindings is another one. It makes it easier to iterate over a set of values. And
string view is also one we hear about quite a bit.
Okay, yeah. It's not one I use very much myself, so can't say that much about it. As I said, there's something for everybody, and a lot of the little things are, well, for somebody else, and we should encourage that. We should approve. Just because I can't use it and I don't have any use for it, doesn't mean that nobody has. The C++ community is huge.
Yes.
I mean, what is it, 4.5 million or thereabout? I mean, there should be something for everybody.
And file system that finally we got.
Yeah, finally.
Because that guy forces me to write code every day.
I am mean.
I actually happen to appreciate. I grew up in the Unix and Linux world. I spent 16 years on GCC and so do POSIX stuff. Now having some common notation for manipulating file system is something I've found quite useful for someone coming to Microsoft
and
Windows platform.
That's something that I've been looking forward to. I haven't done that one all that much myself, just played with it. Azure, on the other hand, is crucial.
Yeah.
So for everybody, there's something.
Azure that works well with coroutines. Gore talks a lot about it. And,
unfortunately, I can't use Gore's coroutines in my real work because, well, it's still in the wrong compiler for that.
A different compiler.
Full disclosure, we love GCC and we love Klein.
and where I work, it's mostly a GCC shop.
Yep.
Can you tell us a little bit more about how you see it? Basically the 17 process is coming to an end, and then we have to start thinking about the future, what comes next. And can you tell us a little bit what the community could expect, or what the general population should ask for, or
Let's see. One thing I have learned from the C++ 17 process is that making predictions about the future is a very hazardous business.
For many other professions too.
Yes. They do say that making predictions is hard, especially about the future.
But we have to try.
What I think, of course we have to try. We can't just sit still. I mean, the world is changing, we're changing, and we can do better, much better. So I've been trying to outline where we can go. I mean, I have a list, talking about it, I've been writing about it, and I think one of the things we didn't get quite right for 17 was that we were waiting to put things into the standard text till they were fully polished. And so we're trying to get something in just a few months, like 8 months or 12 months before we are shipping. That makes people very nervous. So what we should do, in my opinion, this is not a prediction, it's just an opinion, we should take the major chunks that we want to have in 20 and put them in next year.
Early,
Once we have shipped 17, we should not sit around waiting and chatting for 2 years and then trying to get things in. We should put things in. And the things we should put in are things like modules and concepts. And I wouldn't mind to see coroutines, definitely. Ranges, probably.
That's right.
The networking, TS, and possibly some of the more support for concurrent programming. So I have articulated a plan, and I hope that people will consider putting it in early. It's like integrating early for software. You don't find the bugs till you put it all together. As long as unit testing is very good, but you need to get it together in one place. Also, it will teach people that we have made a decision. This is the basis for the future work. Instead of what we are seeing now is that people says, oh, it's not in the standard. I have a new idea that is rather different, and we should go my way instead. And now we have to deal with 3 or 4 independent directions, which gives people settle in their attitudes, in their opinions.
So what you're saying is that early integration focuses the mind.
Yes. First you have to decide what you want to integrate, and then you have to put it all together and see how it works together.
So you talk about the evolution of C++. You mentioned earlier the dark ages and where we are. And I think I was probably in kindergarten when you were doing whatever you were doing. What would you say today, where we are today, compared to, let's say, early 90s when standardization started for C++?
We are much further on. I mean, the foundation of C++ is roughly two things: good use of hardware and zero overhead abstraction. And this came from the earliest days, and it is the basis now. We saw a beautiful keynote today, plenary today, about how to use C++ to do absolutely zero overhead using C++ 17 to program a Commodore 64.
Yeah, with all the right high-level abstractions.
The right high-level
Blast from the
abstraction,
past,
modern
yes.
things. There was structures, there were lambdas, there was all kinds of good modern stuff. And it compiled. I was reading the assembly code that was being shown on the screen. And you know, I think most assembly programmers, even back in the Commodore 64 times, would have had trouble writing code that tight. And you could say, why would anybody do an old computer? And the answer is, the old computer has a spec that is not that different from a microcontroller. So if you can do that, you can do a microcontroller. One of the things people says, but what about the overhead from exceptions? And he says, well, I didn't use any exceptions. The compiler figured that out and generated no overhead.
Yes.
I mean, zero overhead means zero. It was really, really impressive what he was doing. And so that's an approximation of the earliest ideals that just was far better than I could barely have imagined it.
So we do have pretty good language to
We have
write tight,
we have a good
solid
language for tight code. I mean, arguably optimal code. I mean, it is very much better at it than it was 10 years ago or 20 years ago. And we can do abstractions that match the application area much better these days, and we can afford to do it.
So now we've got the future, which is, of course, the internet of Commodore 64s.
Yes. I mean, that one was so small that it's even smaller than the machines I developed C++ on.
Right.
So that's really small.
So for someone who is junior, graduated or getting midway in higher education, what advice would you give that person in terms of just programming and then usage of C++ or some other language?
I mean, that's really hard. I mean,
That's why I'm asking the
community, the software development community is huge. I would say try to take a broad perspective on things. Don't obsess on one little corner. Don't be a language fanatic. Don't be an operating system fanatic. Learn the fundamentals. Spend time on things you don't absolutely have to do before tomorrow, whenever you can. So broad-based. Take it serious. I mean, somebody says program as if it mattered. It does. Our civilization is based on it. And think that you're building for a long time. Build up a portfolio of skills. And there's so many things that one could say. A bit of idealism is always good.
Yeah. So one of the things that people say is, C++ is so complicated. They don't know where to start, right? There are the teaching books, and when you get hired as junior dev, then you don't get to start with your own little main function. You get plunged into an existing code base, and you get to learn the tribal knowledge. And so I know you have been developing the guidelines, and are there any things there you want to to tell junior
Yes.
devs, not just junior
Yes.
devs, but old dinosaurs like me.
No, the point is that when we move into a new company or into a new application area or just into a new team, there's a lot that has to be learned because there's great varieties in the way people are doing it. So the way I look at it is you have to try and get the big picture. And so the way I look at it in terms of C++ and things like that is, this is what I would like. I mean, I was dreaming about something many years ago, and it's getting closer now. It's an approximation. But if I hadn't had a dream, if I hadn't had a view of what I would like, and if I hadn't thought a little bit about what the ideals were, I would have been lost because I wouldn't have known which approximation was better. So when you go in to a new organization, bring your ideals with you and see how you can bring the code base, the procedures, the interactions with other developers closer to your ideals. And yes, you have to evolve your ideals over the ages, over time, and this is what some of the textbooks are for, especially for C++, the tour of C++, something you can read in a weekend or in a day. Lots of people have, so I know it's a fact. to get a modern view, instead of looking at the code base and saying, yuck, this is ugly. You know, all old code bases are ugly in every language.
Yes.
Happens to the best of us.
It happens to the best of us. We do our best and then we learn something. Otherwise, we wouldn't have progress, right? And so, for the tour to get an overview, and then we are developing, we being somebody at Morgan Stanley, somebody at Microsoft, a lot of people out in the community. It's an open source project trying to define what would we like future C++ to look like. What would the code look like if we could just write it the way we want to? Because that's the first thing to decide.
Yeah, but we also want to ensure that the code get compiled with
and such.
the
So this
compilers we have today.
This is the ideal, and so there's a set of rules that brings it down from the philosophical.
core guidelines,
Yeah, the core guidelines, which brings it down from this sort of vague, idealistic level to concrete things. How do you choose between the different ways of passing arguments? How do you construct a class hierarchy? What is a good simple function so that it runs optimally fast? What is it you should look for performance? Which are the known bug traps to avoid? And you want that, and then you ideally want enforcement in terms of a lot of these rules can be machine checked. There's some in Visual Studio. There's some in Clang Tidy. So we want a tools infrastructure that help people get moving along, and it doesn't matter whether they are just out of school or they've been doing it for 30 years. They can use this help. And also there's all of these old code bases that we would like to upgrade, but they're so ugly that it's sort of unfit for humans.
And safe for life.
Therefore, we need tools to do it for us. A lot of this stuff is very repetitive, and humans are not good at repetitive, especially not smart humans. They bore easily. So we need tools.
Yeah, so actually you're talking about earlier that the guidelines is what we want future of C++ to look like. And I think a good example of that is the structure binding proposal, which evolved out of the guidelines.
At least partially. One of the reasons we got structured bindings that we were looking at uninitialized data, which is a well-known source of bugs. And we were going down trying to trap different cases where we got uninitialized data. Why do people have it? Like a big input buffer is a good example, but there's a lot of bad examples. And one of the things we found was that people need to initialize 3 variables, and they need a function that that computes those three variables for them, or one that does two and one that does. Basically, there was a gap. We have the uninitialized variables up here. We have the so-called initialization down here, which is a piece of code that does assignments. And what happens in here? if you use it there, you have trouble. Yeah. Furthermore, some things are default initialized, so we do work, and then we throw the default value away down here. This is inefficient. Yeah. So from there why can't we just take three variables and initialize it with a function that produces three values? And from there we get structured binding.
Nice.
Yeah. So
there's also other sources for it, but that's one of the roots of that idea.
Probably one final question from me, and
we should wrap up.
Yeah, it's so you talked earlier. You said you shouldn't obsess with codes, and you have to try to have broader view of what is going on in the community and outside immediate team or organization. What would you recommend for readings that people should look at in spare time?
Let's see. First of all, sometimes, of course, you do have to obsess. What worries me is people who never does anything but obsess about a single piece of code, even if it's one at a time and such. You need a framework for what you're doing. And yes, a good programmer has sometimes, a lot of times, to obsess about a piece of code. Outside, you can have some interest. I read some history on this trip. I'm carrying a history of philosophy in the area of enlightenment with me to read. People have their own. I like to run. I like some forms of travel. People should have other interests. You can't just program. And if you do, you won't actually be very effective. You can't be a good software developer if you can't communicate.
Exactly.
In writing, or by speaking, in little groups and big groups. There's a lot of communication skills necessary. I've never seen anybody with good communication skills that didn't read a lot.
Yeah, exactly. Yes.
And not just technical books.
Yeah. Okay,
great.
Thank you a lot for stopping by and
sure, it was a pleasure, and it's been a fun conference.
Yeah. Okay, thanks.
Thank you.
Thank you.